Greetings and welcome back to another flipped math lesson with Mr. Valleau. Today we're going to be looking at solving polynomials in factored form. Now, we've worked with polynomials in the past and we understand what a binomial is and a trinomial, and those independent terms join together to form your polynomials. And today we're going to look at what it means to solve those polynomials when they come to us in factored form. Now, the first thing we're going to talk about is what is factored form. So here on the left, we have two polynomials in standard form. And what we need to look at is how do we adjust them then into their factored form. Now, factoring means removing terms, removing like terms, and breaking apart a polynomial. So in this case, let's look at the first one. We have x squared plus 3x. So let's take a look at what happens when we begin to factor. Now, the like term in both of those terms is our x term. So let's remove one of the x's. And what we'll do is we'll move the x to the outside, and then we will have a parenthetical expression there. So if we take an x out of both terms, we are left with x plus 3. And this allows us to factor out into and break apart the expression so that we can work with it as we move forward. Now, the other expression is a little bit larger. What we have to do then is we have to start by breaking apart the constituent pieces and how they fit together. Now, the key here when you're factoring a trinomial or you're factoring a larger polynomial is that you need something that will multiply. So you need something that will multiply to get this term, but will add to get this term. So if we start to work with this, let's break apart our factors of 24. So we have 24 and 1, and that's not going to work because that will not add to 5. And we have 12 and 2. And again, something that will not add to 5. And we have 8 and 3. Now that's getting closer. So let's take a look at 8 and 3. And then we realize what we need is a negative 24. So if we have an 8 and a negative 3, that would give us a negative 24, and would also add together to result in 5. So let's, in this case, let's break apart our trinomial into two binomials. Now we have two x's, so we know we are good to lead with the x in both of those. And then we have to put in our terms that we figured out on our factoring. So we have our negative 3 and our positive 8. And that has our terms factored. And it's important that you know the basics of how to factor terms, because now we're going to look at how to solve once terms are factored. And what we're looking at first is what is called the zero product property. And the zero product property says when one side of an equation is a polynomial in factored form and the other side is 0, the factored parts can be separated and each of them set equal to 0 and then solved. So let's take a look here as we lead in with our first equation. So we have a polynomial in factored form, and it is equal to 0, which allows us to break apart into two equations. 3x is equal to 0, and x minus 6 is equal to 0. And then we are going to end up with roots of this equation. So the roots of the equation are the solutions for x, where x will equal 0 and x will equal 6. So we have our roots and we have our solutions for the polynomial. Now on the other side, we've got the same thing. We've got a polynomial in factored form. It's actually a trinomial in factored form. And we are set to 0. So at this point, we can break apart each of those binomials so that x plus 5 is equal to 0, and x minus 4 is equal to 0. And we know then that our roots, our solutions for x would be negative 5 and 4. Now again, we have to look at how are we going to factor these polynomials. So when we start to factor, one of the things we want to look at is what is called your greatest common factor, or GCF. So what you have to look at is what is in common. Well, again, when we look at our factoring of polynomials here in this case, we have 8y squared minus 24y. And so the first thing we look for is what do they have in common? Well, 8 does go into 24, so we know that is a common factor. And we know that there is a y present in both of them. So what we can do is remove an 8y from that binomial, separate it out, and that will leave us with y minus 3 on the other side, which gives us the ability to set this equal to 0 and then solve for the polynomial. So in this case, we'd have 8y is equal to 0, and y minus 3 is equal to 0. In which case, one of our factors for y is 0, and the other is 3. And again, as we start to look on the other side, now factoring larger polynomials makes it a little bit more difficult to solve, but we can do the exact same process here when we are given 12x cubed plus 3x squared. And again, in this case, let's just look at factoring it out. So what we have is our common factor of 3. So 3 is a factor of both 3 and 12. So if we remove this 3, we can remove the 3 here. And we can also remove a couple of those x's. So we can remove, let's remove the x squared, in which case we are left with 4x. So we've taken out the 3 from here, the multiple of 3 from there, and 2 of the x's. And on the other side, we are left with 1. So again, we're given something that we can work with in terms of a solution. So just to give you an idea, you can actually remove the whole thing. You still have 0 on the left side and negative 1/4 on the right. Now the last part, again, we look at solving just like we've done previously, solving by factoring these equations. So what we've got is we're not actually set to 0, so using our 0 product rule will not work. So what we have to do then is we have to adjust this equation to allow it to be set to 0. So if we have negative 10a squared, and let's go ahead and move that 8a onto the other side, and we've now set the entire thing to 0. Now, if we factor this equation, we'll be able to go ahead and solve for both pieces. So our common factor here is 2. So if we remove a 2a from both sides, and let's make it a negative 2a, we'll make it a little bit easier to deal with on the right. So we have 5a remaining on this side from one factor, and negative 4 from the other, and we're equal to 0. So now we have negative 2a is equal to 0, and 5a minus 4 is equal to 0. So one of our factors is going to be that a equals 0, and the other is going to be that 5a is equal to 4, and therefore that a is equal to 4/5. And we have both of our factors. Oh, excuse me, let me go back and make a correction here, because when we remove the negative 2a, that becomes a positive 4. and a positive 4 here, making this a negative 4, and therefore a negative 4/5.